Hey everybody. So this is going to be a technical video for sure, and then it's going to be essentially on what I'm calling Kadane's sliding window. I need to essentially update this. I keep often calling it Kadane, but it's Kadane. His name is Kadane. And then so essentially what this is and how this came about is essentially if like MemGPT is really big, everyone's talking about it right now. MemGPT essentially allows you to have unlimited context and unlimited memory within ChatGPT, which is awesome. It's cool, bueno. I like it, but like I'm starting to just honestly like, get kind of tired and irritated of like all this stuff that's built out for ChatGPT and OpenAI. I don't know, like for me personally, like I don't personally like developing for ChatGPT. Like I'll just be flat out honest with that. Like I like ChatGPT, it's cool, but like I'm not trying to make OpenAI money, right? By like just even with my research, like I'm not like why would I pay OpenAI money for my research when I can do it in a lot of other areas? And then so that's like my overall take on it all. And so that's kind of how I try to approach it. And then so when I see something that's released for like OpenAI only and like only like this is only usable with like ChatGPT or ChatGPT 4, I'm like, man, like okay, it's cool, but like I don't know if I'm actually going to use it at any point. Is kind of how I look at it, right? So uh, I see this MemGPT seems really cool. Everyone's talking about it, right? And then it's like, but then it's like another release where it's like OpenAI only, and then so I'm just like, oh my gosh, it kind of frustrates me a little bit. So very first thing I did is I kind of like dove into the back end of this, right, and figured out exactly how MemGPT works and like why exactly they're relying on GPT-4. And so I understand why they're relying on GPT-4 for MemGPT. It like relies on some complex functions and some callbacks and some stuff that it like you need GPT-4 for that. I understand it. Okay, cool. But so I don't I want something less complex than this then, right? If the issue is complexity, then like they've proven that you can do this and that you can give a model an unlimited context window. So let's go for a little bit of a simpler like solution there. And then so my solution ends up being pretty like really simple to me. So there's an algorithm within computer science called Kadane's algorithm, and then Kadane's algorithm is essentially like utilized for unlimited arrays. Like if you have an unlimited array and you want to essentially get like some sort of calculations on it, that's where Kadane's algorithm comes in. So it's perfect for that, right? And then so like the good thing about that particular algorithm then that makes it really strong for this instance is that it's really good at what LLM models are really good at overall. So that's kind of where my initial thoughts go with it. And then uh, but the problem with it is that it's for essentially like the to like break it down really simply, it's for unlimited arrays, but what we want it for is for limited strings, basically, like for a set amount of strings, but it's meant for an unlimited amount of arrays. So other than that, though, it's perfect. And then so I just like, okay, simple solution there is make it so it rather than being unlimited, give it a limited context window. And then so that's really all this is. And then I can start executing this code now. It'll take a few minutes to run through. It's very simplistic code once we go through it. And then it's really just these two lines. So it's very first thing that I'm doing is just pip installing transformers, and then also this EINLPS package, which I need to install every single time when running the my Phi 1.5 model. Testing on the Phi 1.5 model. This is I really like this model a lot because it's small, easy to use. I know what the outputs are going to be on it because it's kind of undertrained a little bit, but I think that's good for me when I'm doing testing. So I like that. And then when we get to our actual code here, we're just importing a few other packages, collections, and then Torch under the Transformers package. And then from Transformers specifically, the auto model and auto tokenizer, so we can take care of that. And then we're creating essentially what we're calling Kadane's sliding window. And then we're giving it a max lens size, like a window size as to how it works. And then we're calling it and we're classifying it as long-term memory. And then so the goal of this is that anything that falls under Kadane's sliding window, put it in the long-term memory. Very straightforward, right? Like it can't get more straightforward than that to me. And then so essentially this is essentially like the definition of like the self elements within this, and then so it's just defining how the window works, and then like the calculations that it should do for the window, and then it's saying essentially like so, and then for context, like before you do anything, refer to your long-term memory basically. So like if I give you something to like a prompt, then utilize and like incorporate this long whatever is stored in this what we're going to call long-term memory in your response, and that's basically all this next one is doing here. And then this is kind of like the magic or like the adjustability within this, and then so this is like how big do you want to make the long-term memory, and then like the only cap on this is like your GPU size, and then your GPU memory when you run this, right? So, again, the reason why I like this model is because it doesn't take a lot of GPU, etc. The way that I have this code running right now, it's like essentially the memory gets it's storing memory every single time that you execute these calculations, right? So every single time we run this, and then if I run it again, it's going to like essentially we can run it again, and then it's going to get an output again, but it's going to now we've essentially run it 3 times, right? Once, twice, and then now a third time, and then so this third time output is now like keeping all of that in its memory, right? Like that's what we're doing is we're saying, hey, in this instance, anytime that you generate an output or like we're giving you prompts and then you generate a prompt response, that's your long-term memory. Put that in your long-term memory. And then so in this instance, it has up to 1,000 tokens in that long-term memory instance. And then so essentially once that 1,000 tokens fills up, then it's going to run out of memory in this instance. And I can increase that up. We can increase it down. We can increase it all kinds of ways. We can tell it to do multiple and a plethora of different things from here, right? Like this is just like a base implementation, kind of just showing like the world. Like here, it's really simple to me. Algorithm, like kind of like once you understand like exactly how it works and what you're trying to do, it's very simplistic, right? Like this is it. Like this is the whole entire code, and then this is what it gives us, right? And then so. Essentially here at the bottom, what we're telling it and what we're putting it into its initial memory is this story of Alice. Once upon a time, there's a little girl named Alice who lived in a village. One day, Alice was playing in the forest when she came across a strange rabbit hole. She followed the rabbit down the hole into Wonderland. And then we're also telling it that if we give it a follow-up prompt, then we want it to respond to after Alice fell down the rabbit hole, she. And then we also have some code in here where we're telling it like, hey, like you don't have to output these like this context. Like we're saying like don't output it, but it's like the model's still going to output it. I can tell you that from the testing, just because that's how the model works. But we're telling it in the code to like not do that. So again, like you can like this code can be like cleaned up and played around with a lot. Like it can be optimized for sure. But so see after Alice fell down the rabbit hole, she, and then so we can see that it's already like because it's again like that third time, right? So and then it's once upon a time there was a little girl named Alice who lived in a village. One day Alice was playing in the forest when she came across a strange rabbit hole. She followed the rabbit hole down into Wonderland. Alice was amazed by the beauty of Wonderland. She saw colorful flowers. What did Alice learn about herself in Wonderland? And then it's a small village. Alice was playing in the forest when she came across a strange rabbit hole. She followed it down. After she fell down, and then it repeats a little bit. For the second one, after she was playing in the forest, she came across a strange rabbit hole. Alice was amazed by the beauty of Wonderland. She saw colorful flowers. This is right where we ended off before. Talking animals and sparkling river. She decided to explore the Wonderland and see what else it had to offer. As she walked through the Wonderland, she met a friendly squirrel named Sammy. Sammy told Alice about the different creatures that lived in the Wonderland and showed her their favorite spots. Alice was fascinated by Wonderland and couldn't wait to come back and visit Sammy and the other animals. And the reason why I love this Phi 1.5 model is because it's very predictable outputs as to what you'll get from this model. That like you're going to get generally like this type of stuff, right? Exercise 1, exercise 2. That's the outputs that the model will want to produce. So when you get outputs like this, it's very clear that it's influenced by what you're doing before the output occurs on the model. So Phi 1.5 is really good for me for testing in those instances. And then so what you can see from all of this, just really shortly summarizing it, is that we have a sliding window, which is essentially giving the model like long-term memory. And then in this instance, we're giving it long-term memory around a story of Alice in Wonderland so that it can coherently and continuously gives that story and sticks to that story. And then especially with our Phi 1.5 model, which is very bad at that in particular, we can see massive improvement over the like typical outputs that we would get from Phi 1.5 in that particular instance. So I think it's a very good test scenario in that instance all around, and we can see all the benefits. You can see that this is very simple as far as the code. Again, like this is the main code here, and like it's not complex at all as far as like what Cadence sliding window is actually doing. I'll leave the description to the Colab notebook in the description of this video, and if you like this type of content, please like and subscribe. Thank you very much.